just wanted to give you an update on another type of stoichiometry problem. This time I'm dealing with a little bit different problem. So here's the example that I'm given. It says 2.5 grams of sodium react with an excess amount of chlorine gas to form, and I have a blank. How many moles of product will form? And so I know that this is a stoichiometry problem, which is going to use the BCA table because it tells me up here the amount of one substance, and then I want to know the amount of another substance that's going to form. So the first thing I need to do is I need to write the chemical reaction. And so to do that, I need to know that the formula for sodium is Na, and it says it's reacting with an excess amount of chlorine gas. And so chlorine gas, you just need to understand that chlorine gas is one of those diatomic elements, and so therefore you need to make it like that. And the product of that reaction is going to be, well, what type of reaction is this? It's obviously a synthesis reaction because there's one element plus one element, therefore I'm going to form one thing on the right side. It's called the synthesis reaction. The name of that would be sodium. That compound that's going to form is called sodium chloride. The formula for that is NaCl. And so this is my reaction here. And so when it says how many moles of product, I basically want to know how many moles of sodium chloride are going to form. Well, before I do anything, I need to make sure that this reaction is balanced. And so right now I've got one sodium, but I've got two chlorine, so therefore I need to put a 2 over here. And that's going to affect my number of sodiums, and so then you can see that this is now balanced here just by putting it there. Now I'm ready to start my BCA table. So the BCA table, and this is the first time that we've ever done anything with grams, and so what you're going to be tempted to do is this. You're going to say, oh, 2.5 grams of sodium. Oh, you're gonna know to do this. Let me change my font here. I'm going to go 0 there. So on my before, I'm going to call that 0 because I know that product is 0. And then all the problems that we've been doing thus far have been 0 on the afters for the reactants as well. And so we'll just continue doing that for now as well, just like that. Then it says 2.5. And so on the before, you're going to say 2.5 grams, but pump the brakes here. Because when I do a BCA table, what I want to do is I want to compare the number of particles that is changing in a chemical reaction. And so if I put anything in this BCA table other than something to indicate the number of particles, that's an incorrect unit. Only units that indicate the number of particles can go in this BCA table. And so grams does not indicate the number of particles present. I need to first convert grams to moles. In fact, here's your rule, okay? And I will type it out because it's so important. Moles are the only unit to go into a BCA table. If you do anything other than moles, you're going to be wrong. So the question is, how do we go about getting 2.5 grams of sodium into moles? Well, that's a relatively easy fix. I know that, I'll do the work down here, I know 2.5 grams of sodium. I want to convert that to X moles of sodium. Well, according to the periodic table, if I just go to the periodic table and find sodium, I'm going to find that the molar mass of sodium is 23, or 22.99, but we're going to round that to 23. The units, when you look it up on the periodic table, is grams per, this is key, per 1 mole. Now, we've been doing problems like this all year pretty much. And so therefore, when I say units of grams per mole, just like that, I can set up a very easy proportion here. Now, notice that grams are on top, moles are on bottom. I just set them equal to each other like that. How do I solve for that? Well, I just simply cross multiply and divide. So down here I would have 23x is equal to 2.5. And so to solve for x, I'm just going to take both sides and divide it by 23. And so I take 2.5 divided by 23, and you're going to get x is equal to 0.109 moles. So that is an indication of the number of particles of sodium that I have. So now that can go in my BCA table. So that is the amount of before that I have. So 0.109 moles. And so now the rest of this is the same as what we have. So the change I know is minus 0.109 if I'm going to have none left over. It wants to know how many moles of product. Well, I can leave the chlorine blank because it doesn't really matter. But over here, the product is what I really want to know. And once I have something on the change line, I've been telling you this and telling you this, I can fill out the rest of these if I want to. But let's just fill out the product because that's what it's asking for. So what's the ratio of my sodiums here to my sodium chlorides? Well, according to the balanced chemical reaction, it's a 2:2 or a 1:1 ratio. And so therefore, if I'm losing 0.19 moles, then that means over here on the product, I'm going to be gaining 0.109 moles, which means that total I'm going to have 0.109 moles. And that is that. The key thing that I wanted to show you is this simple little addition here is you can never write grams in a BCA table. You have to first convert it to moles, which should be pretty easy.